Awesome. So good afternoon, everyone. My name is Nate Custer. I'm a senior manager at TTC, or the testing consultancy, and hope you had a great time with StarWest this week. The title of this talk is Machine Learning and Testing, and I want to be very clear, this is not a talk about how to test machine learning. It's also not a talk about the future. We're really focused on where things are right now, what's hype, and where we're going. So I'm going to just walk you through the flow really quick. I'm going to spend some time talking about who TTC is, why we care about this, and why they gave me time to do some research and think about it. We're going to hopefully cut through the hype and look at a couple of things where we're not seeing ROI for our clients that are switching to these yet. We're going to look where we are seeing some ROI, and then I want to talk about the characteristics of early adopters. Who are the people, or what's the context that might make or help you do better with this? So let me start with who we are. TTC was founded out in New Zealand. Those are our founders, Mike and Grant up there. Chris is another one of our shareholders and our CEO of the Americas. And really from the start, the key for TTC has not been just about providing testing resources. It's really about helping people test better. So that's been a kind of, and we are the testing consultancy, but what we do is software testing. That's our specialty and that's our niche, you know? I joined TTC 2 years ago. When I'm not at TTC, I'm working on helping clients test software. I'm a big whiskey fan. I also really love to talk about Manchester United. So if you find me around somewhere or see me at a conference or find me on LinkedIn, if you send me a question about whiskey, I'll happily respond for whatever other questions you've got. So TTC has been about testing. How do we do that? There are times where companies just need resources. You need an expert test engineer in a certain subject. You've got to do some performance testing. You don't know how to do it, and training on a new tool. We certainly do that. We also have done testing as a service for clients that need that. So we'll come in and provide the testing. We'll provide the kind of architects, provide the management oversight, and just let you handle all that for you. We focus on both the fundamentals of testing and the technology. And then what we found is that testing is never in isolation, right? We don't just test software because. We test software because companies are using this software. And so we need to help companies get the whole flow working. So we found that digital enablement is frequently something that after we come into a client, we realize that some of the challenges they're having aren't with testing, it's really with their entire process. And so we help work on that, all that kind of stuff too. That's what we do. Let's talk a little about who we do it for. TTC works with a number of leading Fortune 500 clients. I've been working at one of those Fortune 500 clients. It's one of the ones that's actually not on this slide, which is okay. Most recently, and I would say broadly, our experience is really in the large enterprise institutions. And so tools that may work for a smaller company or experiences that may work at a place where you only have one software product aren't really the environment that we're working at. We're working in these kind of larger, more complex Fortune 500 kind of companies. I'm going to talk about the way we work. And the reason I want to talk about this is because this gets, for me, to the heart of why we do what we do, right? There are some situations where you just need a skilled pair of hands. You need someone to come in, do a job, move on. We've done some of that. I've also been asked to do assessments or come in and offer advice. Come take a look at what we're doing, look at how we're using our tools, look at our processes, tell us what we could do better, give us some insights and help us set some goals, and then the client runs off and kind of runs with it. Where we've had the most success and what's most valuable to us is to be a trusted partner for a client. And that means when you've got a problem and you can't figure out how to solve it, we'll work with you to develop a plan. Not like a kind of a cookie cutter approach, like, oh, you should do this model, but really ask questions, learn, brainstorm with you, and then, and this is a key, not just create a plan, but work it. Because every plan, what Mike Tyson said it better. He said, you know, everyone comes ready to box until they're punched in the face. And then the plan goes out the window, right? Our goal is to be with you however reality punches you in the face, and making sure that whatever plan that we develop together, we can actually implement all the way through with whatever challenges come up. So that really kind of leads me to where we are in testing. And I want to frame this as talking about punctuated equilibriums. So we used to think about evolution that it just kind of slowly happened over time. We get a little better every year. There's a new version of Windows every year. A couple new things change. Most of it stays the same. Hopefully gets better over time. Maybe not. The problem is what we've learned in evolution, and what I found in software as well, is that it actually works a lot more like what we call a punctuated equilibrium. So let's see if I can bring up the chart for that. And that is, something happens which changes everything. Everybody has to adapt and evolve to that, and then it kind of starts to slow down, right? We figured this out. There was a time where there was a bunch of new technology, and we go, okay, Web 2.0 happened, and everything's different. Everybody goes and learns it. There's a ton of frameworks. There's a ton of options. And then we pretty much settle on the best of breed. The winners tend to win out, and it slows down for a little bit. And then the next thing happens, and really that process starts all over again. The same thing I think happens in tools too. And we're seeing this wave of new ideas and new possibilities and new demands that have come with the move towards continuous integration and DevOps, that have come with machine learning and the advancements in machine learning, and have come as we get kind of the world changes and software eats the world. So this is a place of punctuated equilibrium. This punctuated equilibrium doesn't just happen to animals that evolve or to software. It also happens to companies. One of the things that struck me, I saw recently that only 12% of the companies that were on the Fortune 500 in 1950 are still on the Fortune 500 list today, right? Something happens, the world shifts, and the companies that can make that leap go to the next transition, and the companies that can't drop off. Eastman Kodak was a huge company. It's a lot smaller today. So what we found is that these periods of uncertainty, when the equilibrium gets punctured, that's actually when you need your trusted partner the most, right? These are the times where everyone's looking around, and the things that used to work or work okay, maybe there's something that's significantly better. Maybe there's a new possibility. And so one of the questions that when I talk to CIOs, to test leaders, I hear over and over again is it time to jump? Is it time to switch to a new tool? And here's the thing. This isn't an abstract question. This isn't a question that you kind of like just ask and throw out there and maybe it is, maybe it's not. Oftentimes, for a lot of the tools that we're going to look at today and a lot of the tools in the market, switching from one automation tool to another means redoing a whole bunch of work. It isn't a small, like, we'll give it a shot and try. It's a for some of these CIOs, it's a bet your job kind of call. It really matters. And so the question, when I'm talking to people in the industry and they're asking me for my advice, I want to make sure that I give them an answers that help make sense and that we provide clarity. Like I said, these are those times where we really want to be your partner. So that for me is the context that where I look at it. And as we got more and more questions about these new tools and is now the time to switch, TTC has asked me to go and do some research to try and get some clarity and to try and make sure that we could really do a good job and give our customers the kind of advice they're asking for. And so that's what I've been focused on. So let's kind of cut through the hype. Gartner said that, you know, these AI and ML tools are right at the top of that hype curve. And let's focus on a couple of opportunities where I've where that seem really promising, but that might not be quite yet. The first is what I've heard referred to as autonomous testing. When I talk about autonomous testing, I've most often heard people talk about it as a future possibility, and it's most often talked about by people who are going to refute it, though there are some companies trying to do it. They're talking about the idea that couldn't you just point a computer at something, have your machine, your AI figure it all out, write all the test cases, automate them, just do everything and do it perfectly, right? When I've heard it most often, I actually have heard it kind of phrased this way. And I'm gonna pick on Michael Bolton a little bit because he's a testing leader and a testing thinker that I admire greatly. And so, we can pick on him a little bit. And nothing that we make, or if I say that Michael's kind of posing a straw man here, it won't hurt Michael at all. He's been around for a long time. But Michael tweeted recently, are you a tester who's worried AI will take your job? And another testing mind I really respect a great deal, Keith Klein, replied back with one word: no. And here's the thing, right? This is most often posed as like most of the time when I talk to testers about this is a fear conversation for them. But also it would be fantastic, right? Wouldn't you love it if someone could do all the boring stuff you don't like? Sure. So I've seen some autonomous testing companies, and there are basically two approaches. One of them is to use like log analysis. So you watch what the customers do and try and do the same thing, and that'll tell you if your software is working or not. And there's some really great testing techniques that are based on like a parallel production with a new version and watching to see if anything changes, or watching logs, or even analyzing stuff. But that's not real autonomous testing. That's just log analysis and learning, right? Autonomous testing, the company I've seen furthest along on this, and this is actually a quote from their website, though I've added a little asterisk to take out their name so that we're a bit anonymous, and because this is not a sales pitch for any tool. They said, our thing, we'll do this, and we think we can generate tests with 90% less effort. And that caught my eye, because for me, artificial intelligence wouldn't be like 90% less effort. It's like I point you at it, I tell you to do it, and you go figure it out, right? And so then I actually talked to them for a while about this. And the way their technology works is the first thing you do is build a model of all the possible data flows through your software that their AI their machine learning can understand. And then it goes and calculates from those flows all the possible test cases. If this sounds familiar to you, that's because this is a formal structured method of testing. This is what testers have been doing forever. There's no magic here. And I went, oh, you just build a model and then it figures it out how to walk through the model? Well, that's most of what I do for testing now. Anyway, that's the hard thinking part of testing, is building the model. And if I get my model wrong, you won't test correctly, right? And they went, Usually we spend about 3 months helping a new client start to get started before the stuff works. I went, oh, wow, you spend 3 months writing test cases? That's not a leap forward, right? That sounds pretty typical to me. And so I want to go back to this one, because for me, the central issue with autonomous testing is actually what Michael talks about here, which is that if you've got an AI that generates your test cases, you've got to figure out how that AI works and if that AI is doing the right thing, right? No one who buys an AI tool and points it and says, oh, it's tested, is not responsible for testing. They decided to outsource their responsibility to this tool, which means that my job changes as a person whose goal is to find the problems that matter to customers and to people, from finding problems in how our software works to finding problems in how this AI algorithm generates the test cases and figures stuff out. And here's the thing, I probably know more about our software than I do about some AI algorithm. I'll probably be better at finding problems in our software than that AI algorithm. And so for me, fundamentally autonomous testing ends up trading, you trade something that you at least should be decent at for something you have even less chance of being good at. It doesn't get rid of testers, it just changes the bar of where they're going to test. And I think it's really fundamentally a trade for something where you're further removed from what you're actually doing and understanding. Like I said, these tools, I've seen some small applications where maybe it works, but if you've got a good set of if you've thought through how to test your application already, you probably will find everything that they can generate. So let's talk about the other kind of big one, and this is the other big hype place. This is the most frequently talked about AI or ML tool, and that is self-healing or self-maintaining tests. It's what everybody wants. And it seems like the silver bullet, right? This is the thing that's going to make everyone's life better. I realized this when I saw this slide in a software testing tool vendor's deck. And they said, this is what an actual tester does. They spend most of their time on test maintenance and only 10% actually testing. But here's what they do with our tool: 70% testing and only 10% maintenance. And I went, oh, wow, that's pretty cool. And then I saw the exact same slide on a different vendor's deck. And what I realized was the reason that this slide is in every software automation vendor's deck isn't necessarily because they actually make it better, but because it hits a real thing that people are feeling, right? Everybody hates doing maintenance. No one enjoys it, but it's part of the job, right? You only care about testing software if the software changes. But if the software changes, you have to do maintenance on your tests, right? Like if the thing isn't changing, it's doing the same thing. The goal of software is that it should do the same thing today it did yesterday, if nothing else changes, right? You know, garbage in, garbage out, or whatever, right? It's only when you change something in the software that you really want to test it the most. And at that point, that's also when you do the most maintenance, because you change something in your software. So your tests have to change too. It's one of those things that never goes away. The problem I realized is that measuring maintenance is actually really hard. So this is where I decided, hey, self-healing selectors is a really important thing. I went to my boss and said, I want to do a research project. I want to start with some software that's 3 years old. I want to automate it with a couple of different tools. I want to then, and I'll make the exact same test cases against the exact same bit of software. Then I want to upgrade that software through each upgrade release that's happened over the last 3 years, and I want to measure how much maintenance there is. Because the problem with measuring maintenance is that we can't always measure it, so we approximate it. Like, oh, well, how fast did you create the tests? Well, that'll mean that your maintenance will be lower too, right? And anyone who's used a record and playback tool knows that fast creation time doesn't necessarily mean less maintenance, right? We've all had that experience. Or they'll say, we'll change tools halfway through and measure how much maintenance there was before and how much maintenance we spend now. And even then, like, did you make the same level of changes that you did before? If I tell a bunch of developers that I'm having to switch my automation tool because you're causing so many maintenance headaches, I hope they would actually start changing stuff less. They'd realize that, oh, I'm doing things that are making it harder to automate. Maybe I should stop that. The company spent a whole bunch of money to try and fix that problem. Maybe I can do better. So there's a real risk in terms of measurability. This way we could actually go back and see how much maintenance did each of these tools take on the exact same software, upgraded through the exact same versions over 3 years, right? Here's what we found. So we started with 3 frameworks. We did one an open source Selenium framework, one a commercial automation tool, and one of these new self-healing machine learning tools. What we found was actually that the machine self-learning tool had the highest maintenance cost, not the lowest. Certainly, I wouldn't want anyone to rewrite their tests based off of this. When I dug a little bit why, I found that the machine learning was working as designed. It would heal stuff. The problem is that most of the time, the stuff that it healed was stuff that my test that didn't break with the other tools, because we were using intelligent choices of selectors, right? So yes, the date on the URL changed, and the machine learning went, oh, it used to be this date, but now it's this date when you ran it today. I fixed it. But my test case was looking at the URL and had that wildcarded because we knew it would change, right? Humans were already doing most of the things that the intelligence was supposed to address. And the other part was the one time where machine learning had real trouble that, like when it went wrong, the test ran off in an entirely different direction. And tracking down which element it had learned wrong and fixing it took a lot longer than any kind of other updates where it failed and I was at the step where it failed, right? So having done that, our conclusion was these self-healing selectors are cool and they do offer some advantages, but it's not worth replacing your existing tools yet. So where are we seeing return on investment? The place that we're seeing it the most right now is actually in what I call test selection or impact analysis tools. How do you understand this? I think we've all been in situations where you find a critical defect, you've got to push to production right away, and you don't have time to run your whole test suite, right? And you say, why can't you just run the important stuff? I know that when I was building automation for my last company and was in charge of that, I talked about wanting to have a series of different plays in the playbook. So I could call whatever play was most appropriate to the context. Oh, we're only doing this, let's just test that area. It's something that intuitively makes sense, but all too often deciding how to do that every single time there's a change takes too much mental effort. It's just not worth the return, right? I could spend 30 minutes figuring it out, or I could run everything and it'll be done in 30 minutes. I'll have my answers. Are there some tools that can do it? Yeah, we found a couple of them. Facebook actually had this problem because they had a whole bunch of tests. And they published a white paper on this. They were running just 5% of all their tests, and they were catching the right stuff on a per commit basis. TTC has piloted a tool that had a similar results to that. We've also seen this kind of impact analysis on commercial software tools as well. So this one looks at it and kind of looks for everything that's changed, and then flags which tests cover the things that have changed, and only those. And then it goes a step further. It's able to look at how big the changes are and how many times you cross over those, and to flag the most important at-risk tests. Both of these approaches are based on a machine learning approach, where you look at past failures and you say, oh, this file changed and this test failed. That suggests to me that if you change the same file again, the same test might fail, right? Or has the highest chance of failure. Some impact analysis tools do a little more. They know more about the system under test, but they always break down to this. What we're seeing is huge reductions in how many tests have to be done, and that leads to a huge speed up in cost savings. So I remember the way I helped decide how many systems to test and how far to parallelize my tests was around a 15-minute SLA. I wanted a developer to submit a change request, and within 15 minutes to give them an answer of thumbs up or thumbs down. What we found is if you go more than 15 minutes, they'll switch to some other task and they'll come look at the results in 3 or 4 hours. And then they have to rethink and go back and understand everything. If they can watch those test results come in a short enough period of time, they don't have to reset their flow, and they actually fix the issues when they happen a lot faster, because it's still all in their short-term memory, right? Similarly, if you're paying by the if you're paying by compute resources, or if you're using a tool like maybe Sauce Labs or somebody else where you're paying for your test execution, it's really easy to see your ROI if you ran less tests. And it's really easy to see if by running those tests like once a week or kind of on a slower basis running all of your tests, you can actually catch errors a lot earlier too. So we've seen that the speed up in how soon people get results and the speed up that they get around the reduction in how much execution has to happen has direct ROI impact. So what do you have to do to take advantage of that? There are a couple of things. The first is this kind of presupposes that you have a pretty good test automation coverage, right? If you've only got 5 tests, well, one, running 1 out of the 5 doesn't save you that much as compared to running 5 out of 1,000. The second thing is you need to have enough test coverage that you can actually have a reasonable expectation of finding most bugs with your test suite. These systems also work best when the changes are small. So if you were doing this on a once-a-year upgrade, you're probably going to end up running 80% of your tests once a year, right? If you're doing per commit testing, if you've got a kind of continuous integration and really you're moving towards a DevOps culture, I think you'll find a lot more success there. So those are the kind of companies we see where it works best. And that kind of leads me to my last topic I want to talk about. All 3 of these technologies, there are people that are succeeding with them, and there are people that haven't succeeded yet. None of them, to me, are technologies that are never possible to work. So I want to talk about what works and what I would look for, and where, if I would kind of match some criteria, I would say maybe I should take a look at this earlier than everybody else. What's the profile of an early adopter? For autonomous test generation, I had a client that came to me and said, I've come to this company, they have no formal QA practice whatsoever. Can you help me? I just need something to get me started. And in that kind of a case where they don't have any kind of existing test plans or charters, maybe, and no formal experience doing that, something's better than nothing, right? If you've got detailed logs of how your application is being used, that really helps these tools. If you don't have the skill set or budget to bring in a big test team, outsourcing your testing might be a better approach. And outsourcing it to a computer is a lot cheaper than outsourcing it to people, right? Computers tend to do computation tasks cheaper than people. If your workflows aren't really data dependent, do you have a website with 5 pages where you're just clicking around your navigation menus? That might work well. If you've got an invoicing system that has different pricing strategies based on all of the properties of a customer, that might really struggle. So you need to understand your application. And these tools tend to target either the web or mobile applications, sometimes just web and mobile, but they're not typically targeting the full breadth of enterprise applications. So if you've got native applications and Java forms and a mainframe and web and services and everything else and batch systems and pub sub pumpers, etc., this might not be it for you. And my final one is we've got some clients where there are regulatory rules around testing. And if you just kind of do a jazz hands and say, yeah, the AI said to do it, so we did it. Cool, right? That won't fly in a highly regulated environment. So these would be some places where I would look to you at. Self-healing selectors. If you're just starting to build automation, I would recommend building one that had self-healing selectors as part of the process. Most of these tools will also allow you to make intelligent choices as a human as well. Most of the self-healing selector tools are web or mobile apps only again. And if you don't have an existing tool, not that risky to make a bet here. One caveat on a really bad fit, there are some kind of widely used commercial platforms. I'm thinking SAP. I'm thinking like Salesforce. These are things where lots of people build lots of different applications on top of. Both ones we think about and some new ones. I mean, my mother actually explained to me that she was learning Salesforce. And I said, Mom, you're a school nurse. Why are you learning Salesforce? And her answer was, because that's how we're doing all of our contact tracing, right? And so they were like, hey, Salesforce notes contacts and you can mark, oh, so-and-so is supposed to touch base with so-and-so. Here's a result of what happened. For tools like that, there are often domain-specific knowledge that you can use, and there are tools that are custom built to exploit that domain-specific knowledge. So there are tools for Salesforce that are honestly better than any kind of generic tool. So if you're using a platform that already has domain-specific tools that are built, I would look for one that could do that. I think you'll have a lot more success. Impact analysis we talked about a little bit, but high automation penetration rates, per commit testing, ideally, you've got a CI/CD pipeline, and even better, are you paying by test use execution? So if you're paying for device farms or Sauce Labs, or you're spinning up your execution on AWS, all great examples. I'm working at a client right now that the test environment includes a mainframe with a large nightly batch process. Impact analysis isn't super useful for us because we can't, there are tests that we can only run once a day at most, right? We have to do something, wait for the batch to happen, check it tomorrow, kind of a situation. And so we can't like test a little bit on every commit and then just test once a day for everything. We only get one thing a day. That's the fastest we can go. So if the environment is challenging or inflexible and expensive to bring up on demand, then maybe impact analysis isn't the right place or the right kind of tool for you right now. So my last bit of advice, never trust absolute statements, including that one. All of this stuff is always contextual, right? And one of the great benefits I mentioned, I picked on Michael Bolton a little bit, but it's really about contextual software testing. I believe that all software testing context matters. It's the particulars that in fact sometimes are more interesting than the generalities. We want to be your trusted advisor, right? That's the kind of position we want to be in. I'd love to talk to you about what's particular to you, what challenges you're having, what pain points you're feeling, and maybe are there some things that might help you along. We always love to chat. We're obsessed with quality and we're obsessed with testing. That's why we're the testing consultancy. Like, it's not the most creative of names, but it tells you what we are. So we just love to chat about it. So if you want to talk to us at the virtual booth, we'd love to talk to you about it. My email address is on here. Please drop me a line. I'm always happy to chat. Thanks, everybody. So we're going to have some time for Q&A here and be happy to chat some more about it. Thanks.